Okay, we are looking at problem 15 from lesson 2.8. The prompt here is to factor completely. Factoring means make multiplication problem, right? So we're going to basically get as many binomials as possible with every common factor pulled out. So at the start, what you want to do is look at all the terms and see if there's a common factor for all of them. And let's see, we got 6 minus 24 and 24 as a number. And definitely there's a common factor there. I mean, they're all even, so I know 2 is going to go into them. But I also know that 6 goes into 24. So I can definitely pull out a 6 out of all three of these terms. But I also want to look at the variable component and see if there is a common variable here. And it looks like there is. G cubed, G squared, G. So I can also pull out a G from every single one of these. So let's sort of see what happens when I do that. I have factored this out. You can also think of it as dividing. I'm removing this with division. So I'm setting it up on the outside as multiplication. What's left behind is a G squared because 6G times G squared is 6G cubed. This is going to become a minus 4, right? 24 divided by 6, or 6 times a negative 4 gets me back up there. I'd only have a single G there. And then I'm going to have a plus for here. The G comes out, divide the 6 by 4. So technically this is a perfect square trinomial, which means I can factor using a shortcut. But I'm actually going to set it up without the shortcut at first. I'm going to go through the area model process. I am now only going to focus on this part here for factoring. So when I set up my area model, that will be the pieces that I set up here. So I'm going to put my G squared right here. I'm going to put my 4 right here. I set up a diamond problem to help me determine what goes here and here. And the diamond problem works that it's got to have the sum here because all of these pieces need to add up to that. So I can put a minus 4G here. And then what's true about these little area models is the diagonals always have the same product. So whatever 2 I put here have to multiply together to 4 and G squared, which means I can put a 4G squared up here. So what I'm looking for now is the numbers that will multiply together to get 2 and add to get, multiply together to get 4G and then add to get negative 4. So because they're multiplying to a positive and adding to a negative, I know they both need to be negative. And let's see here, the numbers are kind of small, so hopefully it jumps out at you fairly quickly. The only numbers that would work here are a minus 2G and a minus 2G. Negative 2 times negative 2 is 4. G times G is G squared. When we add those together, we get these. So those are the numbers that I use to fill in my area model. And you may notice right away that these are the same terms. And again, that gets back to the idea of this being actually a perfect square trinomial, which I'll show you after I factor it this way. So now I'm looking to factor here. I got G and G. G times G is G squared. This has got to be a negative 2, right? G times negative 2 is this. Here is a negative 2. G times negative 2 is this. And negative 2 times negative 2 does work. So my final factored answer is, G minus 2 times G minus 2. Oops. Let me maybe zoom out a little bit so you can see this whole thing. Oh, still can't quite see it all. There we go. Now I can kind of see it all here. I got the G minus 2 and the G minus 2 there. I can't forget about that 6G. That's really important. That is part of my final answer. And then the only thing I would say here is that this will actually probably get simplified since it's the same thing and look like this. We'll do quantity squared. Since we're multiplying G minus 2 times G minus 2, it's the same thing. And the standard is that to actually square a single binomial. Okay, so now a moment ago I did mention that I would point out how this was that perfect square trinomial. What you may have picked up on, and didn't need to do all this then, is the fact that G squared is a perfect square, as is 4, that is 2 squared. And this middle term is double the G times the 2 with a negative right there. So when that pattern works, when you got a perfect square here and a perfect square there, and your middle term is double whatever's being squared there and whatever's being squared there, it's that special pattern. In this case, it's the G and the 2. Because that's minus, they're being subtracted. And then that binomial appears twice. So we got there using the area model as well. but either method will get you to the final answer. Hope that's helpful. Message me anytime with questions.